Hi class, so let's get started with another unit section of notes. And so today we are going to do both 2.2 and 2.3. Keeping in mind, both of these are very short sections, so this won't be a very long lecture. But you should have a notes handout by now. And we'll get right into it. So the first unit is unit 2.2, or mixtures. And how we define a mixture is as a physical blend of two or more components. And so there are two types of classes that mixtures are put into. They can either be heterogeneous or homogeneous. And so heterogeneous, this is defined as not uniform composition throughout. Which then we can assume that homogeneous is going to be defined as having a uniform composition. And another term that we use for a homogeneous mixture is called a solution. And so it's important here to define phase, because phases are what make up heterogeneous and homogeneous mixtures. So the phase, it describes any part of a sample with uniform composition and properties. So, defining a phase, all it's saying is whatever you're calling a phase, every part of that phase has to have uniform composition and properties. So, for example, let's think about a bowl of Lucky Charms. You could think of milk being one phase and the charms being the other phase. So another way to talk about heterogeneous and homogeneous mixtures is by phases. So Lucky Charms, is that a hetero or homogeneous mixture? You should have said hetero. And so in that case, we can also define it as C different phases. So we can see the different phases. Versus, if we think about the milk itself is a solution because we cannot see the different phases that go into milk. I'm just abbreviating different as DIFF. Okay. So it's important to understand the types of mixtures because there's so many applications of us wanting to separate mixtures. And here, what's important to note, which is where we're going to start is after this asterisk here, is saying differences in physical properties can be used to separate mixtures. Which we should be pretty confident in knowing what physical properties are now. For example, a physical property could be something's melting point or boiling point, and we can exploit those to separate substances from each other. So, filtration, this is a method that separates solids from liquids. And distillation is a technique that uses, so this is it uses a liquid, or you have a liquid that is actually a combination of liquid phases. You'll boil one out and then condense it back into a liquid in a separate apparatus. So here, we'll define it as liquid is boiled. To produce vapor. That is then condensed into a liquid. And I'll show an example of this in class. Alright, so that's all I had for Unit 2.2. And Unit 2.3 is just talking about elements and compounds. And here we will just define element first, which is defined as the simplest form of matter. And we also have to note that each element has their own unique set of properties. And so when we start to combine elements, that's when we get compounds. And so a compound, it contains two or more elements. And they are chemically combined. So this is a little different than a mixture. And so contains two or more elements chemically combined in a fixed proportion. So it's very specific how we make compounds. For example, if we just pop down here for a second, if we think of combining hydrogen with oxygen to make water, 2 hydrogens for every 1 oxygen is our fixed proportion. And here we're chemically combining them to make a compound, while hydrogen and oxygen are elements. Okay. So here I have a couple keynotes about compounds. Compounds can be chemically broken down. But elements cannot. And another thing is that we have to think about is that properties of compounds are quite different from the properties of the elements that make them up. So what this is saying is that if we look at this reaction here, how hydrogen reacts and how oxygen reacts and their properties are going to be so much different than when they're combined in hydrogen in to make water. So how they act individually is a lot different than how they act as water, is what that is a key thing to note there. And so if we slide down to this matter tree, it is kind of helping us determine, okay, what's a pure substance versus a mixture. And then under pure substance, we can have either an element or a compound. And then in mixtures, we have homogeneous and heterogeneous mixtures. So here, remember the key for compounds is chemically bound. And so in this case, we can separate compounds, or we can separate out the elements and compounds to their original elements through chemical processes. Versus, if we have a mixture, we can separate the mixture using physical properties. Into their pure substances.